Hi everyone, thank you for joining and welcome to Python and R for Data Science channel. Today we are going to continue with the learning we started previously, where we covered an introduction to R and briefly looked at atomic data types in R. And forgive me for saying data types because in R we have objects, so it is object types. So for today we are going to look at derived object types. These are objects derived from atomic types that we looked in the previous session. And don't confuse when we talk of objects in R. Don't confuse it to mean an object in other programming language. An object in R is unique and it is something very different from objects in other programming languages. Take it this way. An object in C++ is something very different from an object in R. An object in Python is something very different and very unique from an object in R. I mean, those two programming languages that I have mentioned, Python, C, and you can also add Java and all others. Objects in those object-oriented programming languages, they are so different. Those are things that are very different. I will not say what they are, but if you know them, those are different from objects in R. So, folks, in R, an object in our case is literally anything in our environment. That is to say, a variable assignment in R is an object. A function definition in R is an object. Dataset loaded into R environment is an object. And literally anything in our environment, it is an object. So let us begin. Let us begin. And today we are starting with an empty R markdown. This is where we will put our code. So first start by describing who are you and what is this. So to do that, we use YML syntax to define now properties of our document. That is the R markdown. You can start with the author. I am Jason Kenywa. Today is the year 2021. Okay, we can start with the month June. Okay, 6 June. Today is 20th, the year 2021. Then what is it? Title. I mean, what is this document all about? Title. We can go for an introduction to R. Introduction to R data objects. Okay, then close your meta document definition property clause. So that is it. So whoever you share this document with will know who wrote the document, when was it written, and what is it about, the title. So to begin with, we start with the setup chunk, and this chunk when we render or when we need our markdown, this chunk should not be included, or it should not appear. So write include equal to false. Then next, okay, you can close now this setup chunk and write neat R. These are neat R options. So neat R, when we are knitting, what should happen? So these are options. Okay, need add options chunk. What happens? Okay, this should be a namespace, so double colon, need add options chunk. Okay, set what? Echo, that is print when we are rendering or we are knitting the document. Echo those other parts. Okay, literally included in this chunk means this will not be printed, but for other chunks we want to set a global option for all code chunks that we shall be writing throughout the document, and we want them to appear when you need your document. So here put it true. Echo, that is now the output of the chunk should be printed into the document that we need, and then results equal to true. Yeah, that is enough. So show us the code and show us the output when we need the document. That is it for the setup. Then next we look at now our objects, our R objects. So to do that, let us begin with a title. The first title will take the first header, so from there we can use second header going onward. So this is R. Okay, these are the derived data. Okay, R objects, object types. They are about 10 in total, but we will look at a few of them, not all of them, and yeah, we will look at a few of them. So these are derived objects, or we can say these are data objects derived from atomic types. That is enough. So if you are not familiar with the previous if you are not familiar with the previous session, please I recommend that you start from the previous session where we introduce now the atomic types, and then come to this. Don't start with this one, because this is a continuation of the previous session. So the first derived type we can, okay, there were about there is vector, the derived types. We have vectors, we have factors, we have list, we have matrices, we have arrays, we have data frames, we have table, we have data.table, we have dates, and several others. So we can start with the vectors because this is the building block. Most of them will be built from vectors other than dates. Dates, okay, you can create a vector of dates, but dates should be considered as an atomic type. I don't know why it is not considered as an atomic type, but let us start with vectors. Yeah. We take a look at each at a time. So vectors, what are vector data types or object types? Vectors. So typically vectors is a combination of atomic types. That is, you take several atomic types, put them together, and at the end of the day you have a vector. So to create a vector, we use function C to create a vector. We use function C, which means now you concatenate, which means now you combine. Okay, which means concatenate or combine atomic types. In practice, let me show you how to create a vector. Create a vector. So we can call it V, or yeah, let us do something realistic. Fruits. Imagine of a customer who came to your store and they need to purchase some fruits, or it's you going to a store to purchase some fruits. So you can put a list of the fruits that you are going to buy in a list. How do you do that? Concatenate or combine. First fruit could be a banana. The second one could be an apple. The third one could be berries. The fourth one could be grapes. The fourth one could be a pineapple, and the last one could be a pawpaw. Yeah. Okay. How do we count objects in a vector, that is in R? We start from the first index is 1. In other programming languages likes of Python, C, C++, Java, we start from 0. So you index from 0, 1, 2 going onward. But in R we index from 1. So if you are subsetting now the fruits, the banana would take index 1. So you would take fruits subset 1 will give you banana. Fruits subset 3 will give you berry, because banana is 1, apple is 2, berry is 3, grape is 4, pineapple is 5, pawpaw is 6. Very important. But first, before we go to subsetting, let us look at what we have in our fruits. Now, to run your chunk, there is this run icon at the top of now your chunk. You can hit that button, or you highlight the code that you want to run, then hit Control Enter, or Control run to give you now this output. Yeah, so you see we have a list of 6 fruits: banana 1, apple 2, berry 3, grape 4, pineapple 5, pawpaw 6. I am repeating that indexing procedure in R, because if you are coming from another programming language, may it be JavaScript or these other high level or low level languages, you might have been using indexing from 0. So in R we index from 1. Very important to note. After we have created our list, also you could check the aggregate data type of your object. So to check that, say class. What class is my fruits object? Fruits object. You see, we have a collective type character. So okay, our constituent elements in our list, or in our vector, these are characters, and collectively the object is a character type. Assume we had another list, okay, another vector with now okay, let us say a customer has come to your store. They are purchasing some item. For instance, we can say they were purchasing okay, of that one. Let us now list fruit costs. We create another vector of how much does each fruit cost, and then we can use now the cost in the fruit and the quantity they were purchasing to compute the approximate amount they are likely to spend on the purchase. So say banana, a bunch or few bunches of banana would cost about $8. Apple, a pack of apple will cost about $12. Berries cost about $7 a pack. Grapes cost about $4. Pineapple going at a cost of about $9, and pawpaw about $5 or 3. Okay, this is something we are guessing from the end. So check data type of your object fruit costs. See the fruit costs we have, these are all numeric types. Remember the previous session we said, or we introduced to numeric types and said how they are defined and how do you know if it is a numeric or an integer. So all these elements in our fruit cost, they are numeric, or you could as well make them to be integers. Yeah, we could have integer types. Yeah, and then check the data types, that is the aggregate data type of your vector, that is an integer. If we had our numeric type, overall we would have numeric type, but if we had a few integers and a few numeric, the overall type would be numeric. Why is that so? R will use the most general class that will accommodate all objects. So assume if we had a mixture of numeric, integer and some character. Let us convert these ones to characters. Yeah, let us have that one as a character. The overall type of the vector would be character, because that is the most general type that would accommodate all those objects. Very important also to note. Why is this one very important? Because assume you add your data set with mixed types. If you loaded such a vector or a column in your data frame, then the whole of the column will be loaded as a character type. So you would have to convert now the column type from character to numeric or integer in order to be able to perform now arithmetic operations that you would love to do for analysis, data processing and all that. Yeah, very important. So next, for vectors, they also take named arguments. Assume now that our classical example, you have a customer, or it is you who has gone to a store somewhere and you are purchasing items. Now storing the items in their own vector, then the cost, the quantity and all that in distinct or in several vectors, that would be confusing. Assume now you interchange this one to mean that, like, okay, these values in this vector, they are not ordered. So typical, that is to mean the first cost doesn't refer to the cost of a bunch of bananas. $12 doesn't refer to cost of apple, or even if they refer, that means you have to recall what index an item is in order to know their cost. In R, you can also create a named vector to make your work easier. That is, you can have your fruits to be now a vector, a named vector. So banana will cost $12. Apple cost okay, banana cost $8. Let us go with the previous definition. Apple cost $12. Berry cost $7. Grapes cost $4. Pineapple oh, and when is today? I am misspelling this stuff a lot. When is today? Today is on Sunday. Oh, should get a life, boy. Okay. Pineapple $9, and lastly pawpaw goes for $5. So what do we have? Let us see what we have. Fruits. This is a named vector. Okay, this is the output, and this is now classical. You see, besides now your item, you get the value. Banana goes for $8, apple goes for $12. So having this our latest definition of our products. Assume now we have a customer who has come to purchase. You don't have to recall now the index of berry to know it will cost $7. You just print your items in the store and just and immediately respond to your customer with the price for the item. They are asking for grapes. You respond, they cost $4. Pawpaw $5, berry $7, apple $12, pineapple $9. I mean, with the second definition now, your work that is not the visual recognition of what there is in your data. It is very easy. And what type is our new definition? So let us see class fruits. We have numeric. Why is it so? The naming goes into okay, the names are considered as column names. So typically our vector contains the cost for each item. So that is why we have an overall class. Okay, all our vector, our object is assigned class numeric. Going onward, I think we can look at vector operations. What can we do now with vectors? How can we generate vectors for some stuff? So vector operations, okay, vector, all these chunk vector operations. What can we do with the vectors? What there is in vectors for us? So let us look at generating vectors. So generate a vector, we can start with a C function for vector generation. So C generator. Okay, assume we want to generate a vector of 10 values from 1 to 10. You don't have to write it all the way is 1 2 3 4 10. You can do that simply using C function. How do you do that? Say my values or my generated values. They are C. You are starting from 1 to 10. You already have it. Print values. Click the run button. You already have it. You have generated values from 1 to 10 using function C. How else can we generate values? Okay, so here we could call it generate vectors and do all generation stuff here. You could also use a sequence function to generate. So values sequence function takes arguments, unlike C. It takes first argument from where are we generating, then the second one to where, and then you can specify either by, that is the incrementing factor. You see, with the C we are limited to, you cannot maybe move from 1 to 3 to 5. That is, you are increasing or incrementing with 2 also. I mean, this one, the C function is incrementing your factor or your generated vector with 1. So with the sequence, you can increment with you can increment with a custom value. So it will take 2 from and the increment what to increment with. Alternatively, if you don't know the value you want to increment with, but you know the number of objects, or the number of objects or elements you want to generate, that is, you want to generate 50 items from 1 to 10. So there is also length out argument that now you use to specify the number of values, items or elements to generate. Let us start with the first one. So you can generate it from 2 equal to 1. Okay, this is from, sorry, but okay, 2 to 10 from how you specify the arguments doesn't matter. So generate values to 10 from 1, increment by 2. So what are my values? Run this chunk. We have 1, 3, 5, 7, 9. Why didn't get to 10? Previously we had up to 10. Why are we not up to 10 now? It is because, okay, the first one we are starting with 1. So 1 increment by 2 you get 3. 3 increment by 2 you get 5. 5 increment by 2 you get 7. 7 increment by 2 you get 9. 9 increment by 2 you get 11. 11 is past our limit. We are going up to 10. So that is why we don't have 10, we don't have 11. Yeah. R new we have a maximum value of 10. So assume now you wanted to generate values between 1 and 10 and you wanted about 20 values or 20 elements. So in that case you don't specify by what value do we increment with. You give another argument. So call it values equal to sequence from 1 to 10 values. Now you want length out. You want 20 values. So values, let us see the output of this. We have 20 values from 1 to 10. The incrementing factor, that is R, computed on its own and did its work. We have 20 values. The first value is index 1 and the last one is index 20. Very important as well. Next, assume now okay, you are not interested with generating a sequence. You wanted to repeat a certain number, a certain value a number of times, or you wanted to repeat a certain vector, each item a number of times. How do you do that? Let us see values. So we can use one vector. Okay, values. Let us repeat value. Let us repeat 5. okay, 3 5 times. So repeat, you want to repeat 3 5 times, so you can specify times equal to 5. What do you get? Okay, let us not even assign this one to any object. Let us see what happens here. So when you specify times, whatever you give, okay, whatever vector or value you give will be repeated the number of times that you specify. Most of the time we don't repeat a value, we repeat a vector. Assume you went vector okay, our customer here want to purchase okay, these fruits. Let us use this one. We have our vector fruits and the customer want to purchase 5 items each or 3 items each. So how do you do that? Fruits, okay, so you could do repeat fruits, that is a vector that we are repeating, and the times of repetition is 3. So let us see, run this chunk only. Yeah, there we go. Banana, apple, berry, grapes, pineapple, pawpaw. Up to that point, then it begins again. That is, it will repeat each item. It will repeat each item after, okay, it will do the first chunk, then repeat again, and so on and so forth. That is, it will now copy our vector end to end. So from this end, bring the other one end to end. Yeah. Then there is another fantastic repetition argument called each. Instead of now repeating or copying end to end, this one now will repeat each element the number of times repeated before going to the next one. Let us see. So here we have banana, banana, banana 3 times, then goes to apple, apple 3 times, goes to berry, berry 3 times, goes to grapes 3 times, then pineapple. You see the difference? Let me run the tool all at once so that you can spot the difference. The first one, that is not using times, it is repeating or copying our vector end to end. Starts with the banana all the way to pawpaw, then starts again banana to pawpaw, starts again from banana to pawpaw. That is 3 times, the number of times that we specified. When you use each, then it will repeat each item in the vector the number of times you specify before moving to the next. That is, it will do 3 banana, then go 3 apple, 3 berry, 3 grapes, 3 pineapple, 3 pawpaw. The order you choose, it depends with you. So it all depends with the use case, how you use the two. But basically, that is how it goes. Next, we can look at arithmetic using vectors. So call this one vector arithmetic. Okay. When we talk of arithmetic operations, what comes in mind should automatically be mathematical operations. And these include doing a sum of the vectors, getting the maximum value in a vector, getting a minimum value, getting the median value, getting the mean, computing the quantiles, calculating the cumulative sum of now several vectors, doing a cosine, cos for trigonometric operations, rounding off. For instance, our generated values here, where we had 20 values being generated from 1 to 10. We had a number of decimal points and want to round them off to 3 decimal points. You can use flow and so on and so forth. So those are the arithmetic operations I am referring to when I talk of vector arithmetic. So we can start with a few. I will not cover them all, but always remember our help tutorial. This is something I covered in the previous session, how you can get help in R. Assume you don't know how to, you know the function sin, but you don't know how it is used or what is it. You can get help from R on the function. So sin is a trigonometric function. This is its description. These are the related items, or these are the related functions, and this is how it is used. So sine, cos, you put your angle, and this should be noted here. I don't know if they have noted it in the description, but this angle should be in radians, not degrees. So you may have to do your own function that converts now degrees to radians. If you are used to using degrees as me, mostly I use angles are in radians, not degrees. It is written here. So normally you may have to write your own function that converts radians to degrees. That is very easy. I know you know how to do it. If you don't, Google is your friend. It is very easy. All you need is to know how many radians make 1 degree, or how many degrees make 1 radians. Actually, go Google how many degrees make 1 radian. That should be 180 also make 1 radian. So 180 degrees make 1 radian. That is 90 degrees make half a radian. Half a radian is So starting with that knowledge, Google, create your function that converts degrees to radians, then feed your stuff. So compute your sine, compute your tan, compute arcsine, arctan, and so on and so forth. So let us look at a few arithmetic functions, and I'll leave a list of those functions for you to go read about them from elsewhere, because if we cover that one here, it means now we may not be able to cover what I intend to cover today. Today I want to cover everything concerning derived type and cover it in detail. So when I tell you do this, please take your time, do it. It is for your own good. And by the way, I think you also learn the best way. The best way you learn it is by doing it on yourself. After I show you how it is done, then you do your own research. So that saying, let me create a sequence of 20 values. Let me create the last sequence we had. Values equals to sequence from equal to 1 to equal to 10, and length out equal to 20 values. Then I can print sum of my values. I get 110. That is the sum. You can also get maximum value in the values. What is the maximum value? Here should be 10. The minimum should be 1. Should be 1. And mysteriously, median is not a value in my values. So also go check out this one, 5.5. This is there. But you should check what are the values. These are the values. So the median is around here, 5.5, between 5.2 and 5.7. That one was computed, but how that was computed, it is upon you to know. Good discover. Other arithmetic operations that you can do on vectors include this one. I had wrote them somewhere. Let me copy them and paste them here. So for statistical functions, there is a square root, there is mean, median, quantile. Let me show you quantile. Maybe this would be interesting. Quantile. Quantile values gives you now the values in various checkpoints. At 0% checkpoint, we have that one. These are the percentile to say. You could also specify your percentiles at your percentiles of concern. So all you do that is props equal to maybe show after every 10%. Yeah. No. C generate C generate yeah, generate generate a vector okay, generate sorry for that sequence. So we generate from 0 from equal to point, okay, from 0 to equal to 1 by equal to 0.1. So after every 10%, let us see the quantiles. Closed. We've not closed something. We've deleted the closing. Yeah, that is what we are missing. So this is it. The quantiles after every 10%. So 10%, 20%, that way. Yeah. So statistical functions: quantile, mean, maximum, sum, cumulative sum, product, and cumulative product. Trigonometric, sine, cosine, tangent, arcs, arccosine, arcsine, arctangent, and so on. Rounding off, there is absolute, ceiling, floor, round. Yeah. Maybe let me show you round. Round our values to what decimal points? 3. So this would be the output. Our values rounded off to 3 decimal points. There is signs. Okay. So always remember, you can also get you don't have to go to Google to know what these functions do and get examples of how to use them. All you have to do, take the function exponential and ask R, what is this function and what does it do, how is it used? Here is all you need to know about the function and related functions. I think I should not spend more time on that, otherwise we will be unjust to other stuff. So last but not the least, let us look at subsetting our vectors. You want to get a certain portion of your vector, so subset vectors. That is getting now a subset of your vector. We can subset from our values. Yeah, okay. Let me have new values to be the rounded off values, that one. And then we want to get item index. I said, okay, let me show you. These are the values we have in our vector, and we want to get 3.368. 3.368 is index 1, 2, 3, 4, 5, 6. So you would say values of index 6. That is it. and you have it 3.36. But if you wanted to get values from index 4 to index 8, that is how you do it, and you have values in that range. You can also perform arithmetic operations from the subsets. That is, you can do you can do this one plus the same, but now from say from 12 to these are 4, so should be about 16. Yeah, 4 yeah, and you have it 8 9 that way. Let me show you what happened here. Okay, the first line, it is the output of get values in the range 4 to 8 and them to values in the range 12 to 16. The second output, it is the values in the range 4 to 8, this one. So what happened to get 8.63 is that R added 2.11 and 2.421 to get this one, and then this one and this one, 6.684 plus 2.895 to get 9.579. Same case, same case, same case. That is what happened. So if you had used multiplication, the same thing would have happened. So it would take 6.211 multiplied by 2.421 to get the output of the result of the first or the output of the index first. So assume here, see, we give the first vector add 4 items, and the second add 4 items as well, and that is how we were able to arrive at okay, these are 5 not 4, sorry. Yeah, that is how we were able to arrive at this result. Assume now we remove one item here from the last one. What will be the output? Let us continue with addition. Yeah, so what will be the output of this one? Warning, the values in the first vector are longer than the values in the second vector, but anyway, here is your answer. How many values? We have 5 of them, but now, okay, let me show you all the values. The first one, we have okay, this plus this one, you get this one, 6.684 plus 2.895 get 9.5, 7 plus 3 get this one, 7 3 get this one, 8 4. So where did we get this value from? Okay, these are 1 2 3 4 5. Okay, we fed up to this point here. So okay, this 5. Let me show you the right one and see what happened and how was it able to get our last value, this one. This value, what R did is it took this the first value here, added it to the last item here, because the second list or the second vector had fewer items than the first. So it took the item in the first index and added it to the item in the last. Let us cross check. So it is 6. Okay, this is 6.211 plus the last one was 4.316. You get 10.527. Correct. That is what happened. So in R, okay, I have done this one intentionally to tell you that most of times in R you don't get useful errors. Assume if we were doing this one in C or Python, it would be an automatic error and our script would fail. I mean, it would crash. It will not execute anymore. I mean, it will not perform such an operation. But in R, it has performed the operation anyway. So you should be cautious and very cautious of what you put or what you give to your interpreter. Here we say garbage in, garbage out. You give it trash, R will give you trash. Yeah, you exchange two-way. It is mutual. Give me trash, I give you trash. Give me something clean, I give you something clean. Yeah, no negotiation. This is R. You should be very cautious with that. So of that one, yeah. So we have subsetted, we have done some mathematical operations, and I think that is it with the vectors. Let us do something else very interesting. Factors. Assume, okay, we have our values, or besides having the values, assume we have another vector. Okay, let us go for our fruits. The fruits here. Yeah, the fruits. This is it. Okay, let us see if we have the fruits. Let me show you something small. Okay, off. Okay, let me call it offside. Okay, this is off the subsetting thing, so you should take note of that. So let us see what we have in the fruits objects. We have banana, pawpaw, and that. So assume the customer want to purchase depending on how expensive a fruit is. So they have requested you to rearrange the fruits in ascending or descending order based on the price. How you do that in a vector? You use the function sort fruits, and now you get the fruits sorted in ascending order. So you have grapes are the cheapest. I mean the cheapest to depend on the grapes pack. It is the cheapest, and then the apple pack, it is the most expensive. So the customer might they might demand that you pack maybe 5 packs of grapes, 4 packs of pawpaw, but just 1 pack of apple because it is very expensive. So but that was very easy. Sorting with that is sorting the vectors. It is very easy use because it is following the normal standard. We know 4 is less than 5, 7 is greater than 5, 12 is greater than 9. So sorting those values in ascending or descending order, that is very easy. But assume you wanted to sort months of the year. You have been given months of the year: January, September, October, November. Then you come to March, then you go to July, then you come to June, and you are asked to sort that one. How do you do that? Okay, the answer lies to factors. Sorry. So let us look at factors. Sorry, factors. So what are factors? Factors are R's way of sorting or storing categorical information. So factors are R's way of storing categorical information. Yeah, that's simple. So we use vectors to sort values that would otherwise not be sorted in other ways that we do. I mean, the sort function is very powerful for sorting activity, but limited when we come to categorical information. So I'll use the classical example of the months. But before that, factors, how it does its work is that it will take a list of the categorical values and create the levels. The levels now are the unique occurrences of that vector. Those are the unique occurrences of items in the vector. Assume you earn a vector, or UN conducted a field research or field activity somewhere, and UN collected data of gender, that is the gender composition in your population. So either way, you would have male, female, either male or female. Yeah, okay, don't crucify me for that, but for now let us stick to male, female, male, female, male, female. So your data would have lots of males, lots of males, lots of males, females, males, females. But you want now to maybe get to know the number of males in your population, or females in your population. How will do that one? You group it into factors, get the uniques, and you're done. Okay, let us take a look. Okay, let us use okay, we can use that classical example, simple or factor, pop my population as C, male, female, okay, this is the data that we have collected, female, then male, female, male, and male, and male, and male. Okay, yeah, let us stop at that point. To convert now this vector into a factor, you use function factor your population, then enclose that chunk and run. What you see is this is the data set, but the levels are male and female, just those two levels. That is what you are given as the levels. So you could also do some operations on that, but I leave that one to you. Okay, let us check the n levels, okay, or the number of levels in our population. So factor pop, that is you've conducted research, you've taken some data and you want to know the unique occurrences are in that. There is a unique function that you can use to unique pop will give you the same thing, the unique items. Then you could now compute the length, of course, length unique, that one, it will give you still 2. But there are situations that you may want, or you may have to come to go into factors, then come to your operations. It all depends. But let me give you a classical use or classical example of how we use vectors now to sort values. So here we can say sort with factors. Yeah, let us sort with the factors. I have my months here. Okay, months of the year. Yeah, dot month. This one can be read month. Okay, we can read this one from our base add function. We go for month dot name. Okay, this will give us our months months in orderly form. Let me show you. So this is we get January, Feb up to December. Let us disarrange our months, and so mine dot months, we disarrange the months, use function sample here months. So this one will disarrange the months and print them now in a random form. Let me show you now what we have. You disarrange them and this is what we get. December, May, September, November, they have been disarranged. Now you want to arrange this new factor into the right order. How you do that? You use a function factor. You use a factor. So we want to do ordered dot months. How you order that your months? So assume, okay, the classical example, okay, think of it this way. This is how the months appear in your data, and you want to arrange them maybe for a visualization function or for some other task. You want to arrange them in the right order, starting with January to December. How you do that? You combine a factor, you create a factor, give it your disarranged months, and then give it now the arranged. That is the levels. Levels are the arranged months. So you can either use your arranged months or use the months from R. R already comes with this one. So do month.name. So it will give you this, the months we started with, and now you can take a look at your ordered months. Okay, these are the ordered months, and now these are the ones which are not ordered. Okay, let me show you the output. Here we go. The first one, okay, preserve it. It will preserve. It will preserve the original. What is this now? Okay, 1, 2, 8, whatever. Okay, the original order is preserved from April to October. It is preserved in the factor, but we have levels having January to this one. So when you do the visualization, your months or your date axis will be arranged using the levels. Very important. So if you want now to get your ordered months in the levels, so you could write levels of the ordered months. Levels of ordered months. Let us remove this one now, it's not useful at the moment. So this is it. This is the factor, and these are the levels. Levels now are the ordered months. That is from January to December. This is the intended order. Assume we had used to sort to arrange our months. This will be messy. Yeah. Theoretically it is messy, and even practically it is messy. See what we are having? April, August doesn't make sense at all. There is no such an order. Yeah. When months of the year are further. So the other type, okay, let us look at, do we look at dates now or look at dates finally? Okay, let us look at dates, then now come to these other subtypes which depend on the vector and factor. I mean, okay, from now the list, matrices, arrays, and data frame, they will be borrowing from vector, but dates okay, can be created from vectors. But okay, let us typically look at dates and then come to that. Working with dates. Okay, to create a date from a string, how you use, we use our function as.date. So call it my date is equal to the month is March 25th 2021. Okay, let me go for January. Okay, this is the date of reference for some activity or an event somewhere. So I want it in date, okay, in converted to date type. Yeah, I want it converted to date object type. How you do that? Use as.date. Now give it your date as a first argument, then the second argument could be the format of your date. Otherwise, if you don't give the format, R will try to format your date, and if it is not able, it will print some error. Let us try without the format. See, we are having some errors because now this format is not recognizable by R. So let us give it the format of our date. The format is we are having month is coming first, percentage month, then followed by the day, then followed by the year. So now when you execute that one, it doesn't give you error. It will automatically print now your date, and this one now is a date object type. So you can do operations. So your date, put that one. So now when you have done that one, okay, let us show the date. So now the date is has been converted from character to date type, and now you can do the operations that you love to do on dates. For instance, you would want to see the month. So to see the month, okay, you can deformat now your work, because now it is in date format. So we wanted to reformat date and see, we wanted to know which day was it, percentage A, which day was it, and which date, percentage D, and which month. We want to see the month now as a string. We had month as number 1 is January, but now we want to see the word January, and now we can show the year. 21 for 2021, 22 for 2022, and so let us see if it works. If this works, it means we have now our date as a date type object. That is it, it worked. So 25th January. So 25th January was on a Monday, and the year is 2021. You can also use this one. You can also use the abbreviations A. Can use abbreviation month, will work. So it is Monday, 25th January 2021. Very good, very good, very good, very good. Also, using dates, you can generate a sequence of dates. Assume you want to generate a sequence of dates from January 25th 2021 to April 1st 2021. Here, if you do the usual generation, I mean if you take now your dates, start adding by 1 and so on and so forth, you need to know where to break for epoch. That is, if you are in 2021, February is 28 days, you need to know that. If you are in 2024, another year where February is 29 days, you have to recall that. You have to know which month takes 30 days and which one takes 31 days. That is too much for you. So I'll makes that one easy for you, and how it does that one, it makes it easy to generate dates from now. You give it the beginning dates, that is the from date, and the to date, and now the incrementing factor. Let us see it in practice. Sequence.date from that is from we can start from date to equal to us dot date or we could do okay, not to let us try length out equal to, we want to get 20 days from this date. Let us see if this works. I don't know, doesn't work because we don't have to, or by along with must be specified. Okay, so length out is not workable thing. By equal to 1, increment by 1 day, and then 2 equal to as dot date. We generate from 2021 April 1. The format equal to this is here, this is month, and then the day. Yeah, that is it. So execute that one, and you are having your dates from 25th January gets to that 1st January, starts 1st February all the way to 27, 28, yeah, 28 February, then it goes to March 1st. So from that look itself, you can see that R is epoch aware. Yeah, it is epoch aware. It knows we count 1 to that one for January, count 1 to the 28th for February, then 1 to that one for March, and okay, let us do it for May, June. Let us do it for June and see. Yeah. So this is April, goes up to 30th. This epoch aware. May goes up to that first. Yeah, very okay. Very okay. One last thing with the dates. You want to know when is today from R. How you do that? It is sys dot date, and this will print today's date. Today's 20th of June 2021. What about time? Sys dot time. This will print now everything. That is the date, the time, and the time zone. This 20th June 2021, 9 a.m. That is at 4 minutes, at 4 seconds East African time. I'm in Kenya. Yeah, that is it. There are other stuff you can do with R with regard to time. For instance, you could get the time zone. Here is it, but this is not important for today. Yeah, Africa, Nairobi. That is my time zone. I think that is it with regard to dates. Let us check at something interesting. Yeah. I think so far, I hope you're learning something and it is exciting to you. Let us look at something funny, something exciting. That is the list. Working with the lists. Working with the lists. And what is a list per se? So okay, these are the lists. What is a list? So I think simply we can say a list is no different from a vector, only that now its elements can be now of different types. Remember, okay, even in a vector we were able to bring now items of different types, but now those were strictly atomic types. I mean, you cannot create a vector with derived types, but now with the list you can also bring derived types, and just anything goes, any object goes. That is, a list can contain a vector, a list can contain another list, a list can contain an array, a list can contain a matrix, a list can contain a function. I mean, like, you can have a function as part of the list. So a list is more complicated and can hold more information and more data than vector, but simply it is okay, you can call it a vector that is now more powerful. Yeah, that is generally saying, but that is illegal to say. That is illegal. That is very illegal. Yeah. So let us create a list of vectors. Okay, let let us see it in practice. Okay, working with the list. Let us call list 1. List 1, it is a list. We can generate vectors, say 1 to 5. 1 to 5. That is the first one. The other one is sequence. Start from 7 all the way to 15 by 3, and the other one is repeat. Repeat 20 3 times. So list 1. Let us see what we have in our list. See, first index as this vector that we generated from 1 to 5. The second one as another vector we generated from 7 to 15, increment by 3, and the other one is we are repeating 20 3 times. That is it. That is a list. You can also create list 2. List 2 could be list sequence. Okay, let us do round sequence 1 to 20. How many values? Length dot out equal to 20 values. Oh yeah, 20 values. Let us move from 5 to 10. 5 to 10. Yeah, 5 to 10. And then let us see list 2. What is in list 2? Oh, remember we used round, so we should specify how is it rounded off to 2 or to 3 decimal points. Not here, but here. That should be here. 3 decimal points. Yeah. Okay. Let us see list 2. Yeah, list 2 has values from 5 to 10. Those are 20 values. You can also create a list of lists. So list 3, it is a list where we have list 1 equal to list 1. A list can be named as well. So when you are subsetting items from the list, when it is named, you use the name. If it is not named, you use index. Then list 2 equal to list 2. So what is list 3? Okay, this is list 3. List 3 as list 1. List 1 as 3 vectors. List 2 as a single vector that we generated from 5 to 10. You see, our list is more complicated and can hold more information and more data than a vector. Next, we can look at subsetting lists. Well, okay. Yeah. Subsetting lists. Subset. I need a glass of water. Let me do that. Wow. I hope today's session is not overwhelming to you, but if it is overwhelming, it is recommended, or I recommend that you don't have to kill yourself for this. It's not a do or die. So you can pause your video, take a break, then come back. It is long already. We have gone for over an hour, and that is acceptable. in the previous session, remember I noted that I will be covering in a single video, or be covering as much as I can to cover for the time that I will not be able to do a video. So I am covering as much as I can to compensate for the period that I will be unavailable. I cannot promise to be doing a video after every 2 weeks. It's crazy here. I have a lot of stuff to do, office work, and I also have a real life to live off the computers. My life doesn't just revolve from office and the computers. I also have a real life. But ideally, I decided this is my career path, so I cannot neglect even a single portion of it. So I will do everything, but I am recommitting myself to doing long videos rather than short videos frequently. So I will be doing long videos once in a while. Yeah, that is it. To compensate now for the time that I will be unavailable. Please, I hope you will forgive me for that. I promised and I could not keep my promise. So this is not a do or die thing. So if you feel overwhelmed, or you feel you need to absorb more information, or go through the script and do the work and work with Google page open somewhere, work with another document. Remember, we end this document here, help.stat. It is very useful. This document has an introduction to our PDF, which can also be found on CRAN, that is cran.rproject.org manuals. You will find this document in PDF form. So if you want to do your coding with that document open, either in PDF or in RStudio or on a web somewhere, please do. Just go with your face. Yeah, that is the word thing, the red thing. Go with your pace. I mean, if you know you are a fast learner, well and good. Let us do it together. Then, but if you are a slow learner, just to go by your pace. So here, subsetting lists. We already have 3 lists. The first list, okay, let us see the list or the list here. The first list has 3 items. Assume now I wanted to get what is in the second index of the list. So it is list 1. List 1. See the difference? If it were a vector, I would use a single brackets, but now I am enclosing my index in double brackets. Should note that one. Okay. I don't. This should be list 1 of 2, not 1. But we can also see what is in list 1 of 1. This is what we have. Then you can now get a specific element in the vector. Yeah, that is 5. You can also see what is in the second index of the list 1. This is what we have. Okay, this is when you are working with a named list. You can use this one. When you are working with named list, is it 3? Where did we name our lists? Yeah, list 3 as named list, so you can subset using the name list 1, and that is what we get. You can also use the index for named list of 2. Yeah, you can use the named with the named list. You can either use the name or the index, but with a named list you strictly you can only use the index. So by naming your list you have an advantage of using the name. And also when you are working with a lot of data, it is good to use the name because names are easier to recall than the index. I think that said, I can leave a small task for you. Let me do this. Okay, list. On list. So I will not do this one. I leave it as an assignment to you. Okay, let us create a list of remember our customer who came to buy. So with the list we can now rearrange our work better. Instead of using now the named vector, we can now bring our items in a better okay, we can do our list better. Let me show you what we are going to work with for this exercise. This is it. We have a customer who has come to buy some fruits and clothing. So for each fruit we have the name of the fruit and its cost, the name and the cost, the name and the cost, and so on, and the clothing the same thing. So okay, this is what we have for our list. It is a named list, you can see. So I made your work easier. So what I want you to do is I want you to calculate the cost, okay, the purchasing cost of okay, what this customer has to pay you for fruits and what they have to pay you for clothing and the total amount they have to pay you. So here calculate amount payable for each category. Okay, and if you can okay, let us make it a little complex. I think just calculating amount payable for each category, that is the total amount for the fruits and total amount for clothing and the total for the whole purchase, that is a little easier. Also you can look at how you can introduce quantity. Yeah, that is, assume they bought 3 packs of oranges, 2 packs of pineapple, 5 okay 5 pieces of banana, 3 packs of apple. I mean, bring quantities: 2 shirt, 3 trouser, 4 coat, and all that. Change things a little. Oh, this is I mean, yeah, okay, this, okay, the orange, these are the pieces they bought. Yep, okay, just play around with it, introduce quantity or price or cost. So you may either consider the values here, they refer either to cost or quantity. If they refer to quantity, introduce cost and now do this calculation. If you take this one to represent now the quantity, introduce the cost for each sub item and do this calculation. I think that is a little complex and it's worth doing. So you can try that. Yeah, try that. You can share your result with us all by commenting below on this video. Yeah, I think that is better. when you do your work, comment below on this video with your result. I'll go through it, and we can also start a discussion around this. I think that is workable. When you do your assignment, please comment below on this video with your result and your working. Okay, let us proceed to another thing. Now we can look at a more complex object type called matrix. So matrices. But before that, let me get a cup of coffee. Yeah guys, I'm back with my mug of coffee. You can as well serve yourself one. So let us rush on the remaining 3 subcomponents. The 3 of them. We will rush a little bit because now we have covered the most important parts. The list, the vector, the factor, the dates. That is the most important thing. The matrices, I don't even recall the last time I used matrices. Neither can I recall the last time I used an array. But with the data frame, I use it oftenly, if not frequently. I use it most of time. So I'll just skim through what is a matrix, and how to create it, what is composed in it. If you want to read more, of course there is Google. That is your first point of reference, and then there are other places, YouTube as well. There are lots of materials over there, not necessarily produced by me, but you know where to get help. So with matrix, basically a matrix is a 2-dimensional rectangular data set, and I mean a matrix is like a matrix elsewhere. A matrix in mathematics, a 2-dimensional rectangular data set. And to create a matrix, we use a function matrix to create it. And the matrix takes a number of arguments when creating it. First, you give it a vector with the data set that you want to create a matrix of, and then you can either specify the number of rows you want in the matrix, the number of columns, or you can specify both. If you specify both, then maybe there is a condition that is not met, then you get a warning. I think specifying both is recommended and it is good. But first things first, let us get started. A matrix. Okay. Matrix equal to matrix of, we create our data set to be a sequence of values between 1 and 20. We want 200 length dot out. Okay, let us, and there is no need of going with a decimal. Okay, we can go 1 to 200 or 1 to 100. Okay, 1 to 100. Then we create a matrix of n by n. So we can do a matrix of 7 by 5. That should be 35 values. N out equal to 35. Then n row, we want how many rows? If we go for 7 rows, then columns will be 5. Let us see what we have so far. Okay, this is what we have. This is our matrix, a 7 by 5 matrix. You could have as well specified the columns here, 5. Assume we had 36 or even 40 values. What would have happened? You get an error, but R will create your matrix as well. Remember with the case illustration I did previously with accessing or subsetting vectors and creating a product out of the subset. R does not crash on errors. It will give a warning and do something anyway. So if you mistakenly maybe write a function that will analyze your data and maybe do a visualization, and there is a problem somewhere, this problem will not be spotted from the graphic because R will draw your graphic anyway, but the error will be printed somewhere. So it is upon you to know how you can handle such cases. So that is a matrix, and that is how you create it. Okay, I think one thing I can look at is the order of the matrix. The matrix is created column at a time. So you can see for the first column it will go with 1, 3, 6, 8, 11, 16. Then second column, then puts data into the third column, fills the fourth, and then lastly fills the last column. If you want to fill the matrix by row, how you do that one is you can specify another argument. So we create the same matrix, but now okay, this is M. Okay, let us leave this one here, copy the chunk. Okay, this is a matrix that is filled by column. So let us create another one filled by row. So how you do that, you specify by row argument and you put it through. So it will fill each row at a time. So this is it, filled by column, column. Then this is it, filled by row. Where are we? What is my editor is misbehaving? Who scrolled all that? I don't know. Okay, this is it. My editor is misbehaving for a reason I don't know, so I leave that one. So this is it, filled by row. So it will fill the first row first, then go to the next row, third row. So this is important to note because okay, for the cases when you will be maybe generating your data set somewhere and you are creating a matrix, so the order matters. How your matrix is filled matters, but that is it for matrix. If you want to learn more about matrix, there are resources out there, but I can cover one last thing using named a matrix and subsetting data from a matrix. I think I can cover those two. So to name a matrix, you bring labels. You bring labels. Let us say matrix labels. This is the row labels, a list of row labels, and the column labels. We have a matrix of 7 by 5, so the row labels should be 7 by number, and then the column labels should be 5. So then we label our matrix by specifying D names when creating. So you don't create your matrix here. Start with the labels and then specify another argument called dim dimension names equal to now matrix dot labels. Then run this chunk. Okay, show the matrix here. So this is what we have for our matrix. Now it is labeled A, B, C, going on one. Okay, yeah, this is labeled compared to this one. And now we can look at subsetting matrix. Subsetting a matrix. So to subset a matrix, you use a combination of row, then row column. So like for instance, if you wanted to get this first column A, you just write comma, then A. This will give you the first column. This is the first column. This first column with 88.35. If you want then to get the first row, so it is A, and then get everything from the column. So this is the first row, this one. And then if you wanted to get an item at a certain index, that is, we want to get the 50.5. It is at, we start with row then column, so it is DC. So it is M of small d, uppercase C. So you get the 50.5. Same case applies now for the unnamed. When you are dealing with the unnamed matrix, I use now the numbers. So if you are looking for the 55, we would go for 4, 3. If you wanted to print the second column, you say M of comma 2. If you want to print the fifth row, you write M of 5. Okay, you just repeat this. M, then repeat this one. You get this row. M, then this, you get this column. Very easy. So next, let us look at arrays. With arrays, an array, okay, while a matrix can hold two-dimensional, is two-dimensional, while matrix is two-dimensional, an array can be of any dimension, and it can have matrices in itself. So that is to mean like an array can be of 2 by 2 by 3 or 3 by 5 by 3 or maybe 4 or ours 5 by 7 and then another 3. Let me show you an array. Let me show you in practice an array. So to create an array, you can as well generate your values. So we generate this one. We create an array of 2 by 2 by 3. Let me show you how it looks. Our array. So this is how the array looks. A 2 by 2 by 3. So it is a 2 by 2 matrix and 3 in total. 1, 2, 3. That is it. That is what now the dimension here means. So if you want to read more about an array, please, you know where to get assistance. Let us move now to the most interesting thing, data frame. This is the most interesting, and this is what you will be using most of time to represent your data set. And a data frame can be thought of as a tabular, a table of data objects. This can be, just imagine working with your Excel sheet with a number of columns, and each column contains maybe can contain data of various types. I mean, you can have a column of categorical values, another one numeric, another one with integers, another one with the logical values, some missing values somewhere, and so on and so forth. So a data frame is capable of holding that, while an array can as well hold data of varying type. I think that was important to mention. With matrix, you only deal with one type. If it is numeric purely. If it is logic, just logic. But with an array, you could have the first matrix here having numeric, the second one have categorical character type, this one logical, doesn't matter. So with the data frame, it can as well hold data of various types, and you can think of it as a data table. To create a data frame, we use data.frame. We use data.frame function. This is how we do it. We create BMI data frame with the gender column, male or female, the height of the person, weight, and the age. Let us see how our data frame looks. So this is it. I told you it is a table. very cool. Okay, an interesting table. You can see already we have this head column is double, weight is double, age we could have it as integer, and now the gender is character. So that is it with the data frame. I think I'll be doing you I will be unjust if I cover much about data frame for now, because this is what we will be using most of time. When we read our data from CSVs, from Excel, or from any other source from a database, we will read the data and it will come as a data frame. We also have other derived types, the likes of table, and then there is also a data.table. There are specialized packages that are used now to manipulate data frame and data.table. There is a dplyr package. Okay, this one we use data.table package. Then to manipulate data frame directly, to manipulate data frame, you can either use work with it as a table, or use this package. We will look at it in another session called dplyr. Yeah, this is a very interesting package to look at. So I think for the sake of now, for the sake of your understanding, I would love to stop at that point, come back to data frame, and then look at these two packages. So the table and data frame, these are derivatives of the data frame, and by use of these two packages, data.table package and dplyr package, this is part of the Tidyverse the Tidyverse collection. So we will look at these two in the next session. Yeah, let me stop at that point so that now we can have some good time to explore our data frame better and in depth. If you have made it that far, I thank you very much. See you in the next session. Bye.